Okay, this is a question on geometry. It says in an n-sided regular polygon, how many distinct values can the length of diagonals take? Okay, so we have options. The best way to go about this particular question is let's take various examples. Let's start off with first regular polygon with 4 sides. Let's say this is quadrilateral. The first quadrilateral, regular one, which is a square. Now the length of the diagonals of both of them are going to be same. So number of distinct lengths of diagonals in the case of a square we have is 1. Let's talk about pentagon, a regular pentagon. So if you look at a regular pentagon, this is one diagonal that we have, and this is another diagonal that we can have from a particular vertex. So the length of both of them is also same, so we will have 1. Now let's talk about the next polygon, regular one, which is, let's say, a regular hexagon. So in a regular hexagon, this is the length of one diagonal, this is the length of the other diagonal that you can have, and this is the length of the third diagonal. Now they both are same and this one is distinct, so we can have two distinct lengths of diagonals. And instead of drawing a 7-sided regular polygon, let's talk about a triangle. A regular triangle, which is an equilateral triangle, has got 0 distinct length of diagonals. Okay, now if we take the number of sides n as number of sides, and if we generalize it, so if we have 4 sides we have one diagonal, if we have 5 sides we have one unique diagonal, if we have 6-sided regular polygon we have 2, and if you have a 3-sided figure it should come out to be 0. So by putting the values of n as 4, 5, 6 and 3, let's see which all values give us the answer. Okay, let's start with the first one. Putting n is equal to 3, we get this as 0, so A can be the answer. Putting n is equal to 3, we can have B as the answer. Putting n is equal to 3, C will not give us the answer. Okay, now let's put the value of n as 4. Let's talk about the square. If it is 4, we should get the answer as 1. Putting n is equal to 4 in the first one, A doesn't give us an answer. Putting n is equal to 4 in this, we get half as the answer, though this is not possible. Putting n is equal to 4, we get C is equal to 1. So this is possible. Let's put 5. That is, let's talk about regular pentagon. Putting n is equal to 5, we will have the number of diagonals in this as 5 in the first option. Putting n is equal to 5 in this, we will have one distinct length, which is true. Putting n is equal to 5, we get a fraction. So we can see that either it's option B or C. B works when we have odd number of sides, and C works when we have even number of sides. So let's confirm this with the regular hexagon. If we have regular hexagon with even numbered sides, so let's put n is equal to 6 in the C option. So we will have 6 minus 2, 4. 4 upon 2 will give us 2. So the right answer is D.